Hello, my peeps. This Algebra Nation video will cover the right side of page 77 and the left side of page 78.
Got the following system of linear inequalities. This first one is not y equals. You have to solve for y. It usually takes about 2 steps. 3x plus 2y is less than 6. Remember, treat this like an equal sign. Subtract the 3x from both sides. If you need to, pause the video, write that down. Divide both sides by 2. Remember though, you're dividing everything by 2, giving you y is less than negative 3 halves x, plus 6 over 2 would be plus 3. So in this case, our y-intercept is 3, our slope is negative 3 halves. Our y-intercept is 3, 1, 2, 3, and our slope is negative 3 halves, going down 3 and to the right 2. This is not equal to, so it's not solid, it's dashed, or dotted. Y is less than would mean I shade below. Next up, y is less than 3. Ooh. What kind of line is this? This is just a horizontal line. Remember, y equals a number is a horizontal line. Also because there is no x, which means the slope would be 0, and the y-intercept is just 3. So y equals 3. Remember, y with just a number is a horizontal line. X with just a number would be a vertical line. Remember that. So here we've got y is less than 3, so at y equals 3, I would have a dotted line, or dashed line, same thing. And I want less than, so I would shade below. Where do both regions intersect? It looks like they're going to intersect right in here. That's where I see both colors intersect overall. So in this region, right here is the idea. Speaking of the idea, I think you got the idea of just graphing two linear inequalities. So with that in mind, I want you to go ahead and give this a try. So ready? Get ready to pause the video, try it, graph this system of linear inequalities. So ready? Pause now. You have to first solve this one for y, though. You have to first solve this linear inequality for y. 2x minus y is greater than or equal to 3. Start by subtracting the 2x over. But remember, you have negative y is greater than or equal to negative 2x plus 3. In this case, you would divide or multiply both sides by a negative 1. What was that one rule for inequalities? What was that rule? Whenever you multiply or divide both sides by negative, you have to switch the direction of the inequality. Y is less than or equal to 2x minus 3. As I distribute the negative, I flip the direction of the inequality symbol. So in this case, the y-intercept is negative 3. The slope is 2. Rise 2. Go to the right 1. This would be a solid line. Y is less than or equal to, less than you shade below. Again, if you need to, you can always pause or go back, make sure you have this all written down before we go ahead. X. So in this case, x is a vertical line. X equals a number is a vertical line at x equals 5. 1, 2, 3, 4, 5. So at x equals 5, I would draw a vertical line. And remember, for x equals, it's not above or below, it's left or right. X is less than or equal to less than. For x's, less is to the left. Greater is to the right. Less is to the left. Less is to the left. Less is to the left. So we shade. To the left, to the left, to the left. Okay, where do both regions intersect? It looks like that it's going to intersect by, I kept on drawing that red line. Sorry, just a little more. It looks like it's going to intersect right up in here. Awesome. Hopefully you got that as your answer to see where both regions intersect, because guess what? It is time.
For a brain break. Here's your brain break. I'm thinking this kid's a future pick of the LA Lakers. And the donkey, it pains me to say this, the kid dunking is probably a future pick of the Miami Heat. Ding! That sound, yes, you're correct, means turn your page.
Let's beat that test. Remember, you're probably not going to be graphing these, but you're going to have to use the graphs to answer some questions here. Which quadrant does the solution to the following system of inequalities lie in? So, in this case, if I was to draw my own axes, let me grab another marker. Hello, I'm back. Little x-axis and y-axis, excuse me, a little y-axis and x-axis. Careful, x and y. X is less than negative 3. Okay, so I would go to x is negative 3. And remember, x equals number is a vertical line. So that would be, of course, a dotted line. And x is less than is to the left. So I'm going to shade to the left. And I should have used the same color marker here, blue across the way. So let me just go ahead and etch over that a little bit. Y is greater than 0. Y is greater than 0. Y equals 0, of course, would be a horizontal line, and y equals 0 is also the x-axis, because all along the x-axis is where y is 0. That also would be a dotted line. And I want to shade y is greater above. Remember your quadrants? First quadrant starts in the upper right corner. It goes quadrants 1, 2, 3, and 4. And it looks like both regions are shaded in quadrant 2 would be the answer. The answer would be quadrant 2, where both regions are shaded where it intersects, where the solution lies. Speaking of which, instead of asking for a quadrant, they could ask, which coordinate is a solution to the following system of linear inequalities? So again, you would have to draw yourself an x and y axis, x-axis, y-axis. So with that in mind, let's see, y is less than or equal to x minus 5. The y-intercept is negative 5. If it helps, go ahead and draw a bunch in each direction. I didn't do that for the last case because it was just x and y equals. But in this case, it looks like we have just a little bit more than just an x and a y with a number. The y-intercept is negative 5, and oh, by the way, pause the video, write this all down. That was kind of fast. Slow it down. Pause. Draw it. Y-intercept is negative 5. What is the slope? Remember, that is 1x. So it goes up 1 and over 1, meaning up 1 and to the right 1. That would be a solid line. I'm going to shade below. Now, you got to be careful because you really want to be careful when you're trying to figure out these points. Next up, y is greater than negative 3 halves. Well, in this case, the y-intercept is 0 because there's no number afterwards. There's no constant. If anything, it would be plus 0. The slope is down 1, 2, 3, to the right 1, 2. That would be a dotted line, or dashed line as it's called sometimes. And y is greater than, I would shade above. So this is the region. So let's go ahead and figure this out. Which of these points will be in that shaded region? 0, 0. Is the origin in that shaded region? No. 4, negative 3. 1, 2, 3, 4, down, 1, 2, 3, so 4, negative 3. That's probably the answer. But let's check the others. Negative 4, 3. Negative 4 in the x, up 3 in the y. That's not in any shaded region. And negative 4, negative 3. Negative 4, negative 3. It's not in any shaded region either. So we can narrow down to one answer. If you can't, well, guess what? You can check by plugging this point in and making sure both inequalities are valid. Meaning, x is equal to 4 and y is equal to negative 3. So right now I'm done. We have the answer. But let's check. Let's plug it in. Into the first inequality, y is negative 3. X is going to equal 4. In the second inequality, y is negative 3. X is equal to 4. If I was to simplify each of these cases, the first inequality, 4 minus 5 is negative 1. Is negative 3 less than or equal to negative 1? Is negative 3 less than or equal to negative 1? Well, yes, it is. 2 goes into 4 2 times. Negative 3 is greater than, negative 3 times 2 is negative 6. Is negative 3 bigger than negative 6? Is negative 3 greater than negative 6? Yes, it is. That means that inequalities, which verifies that we do have the correct point. So again, plugging in to verify is another great way to check a system of linear inequalities. And again, try and use two different colors so you can see visually where the two shaded regions overlap.